So for this problem, it was suggested that I'd use trig sub. But before that, we can simplify this further. Completing the square, we'll get this. Taking away a squared from each term, we'll get this. Since a squared being a perfect square under a square root, we can rewrite this as a single a. Also, this polynomial, from its expanded form, I turned it into its compressed form. Since a is just a constant, we can bring it out of the integral and we'll get this. So we can now continue with our trig sub. We let x over a minus 1 quantity squared be equal to secant squared theta. Solving for x, we take the square root of both sides, we'll get this. Take note that x over a minus 1 is equal to x minus a all over a. From here, we transpose this negative 1 to the other side and we'll get this. Solving for a, we'll multiply both sides by a, so we'll get this. Differentiating, we'll get dx is equal to a secant theta tan theta d theta. So from that, we can now write our right triangle with like this. The definition of secant being hypotenuse over adjacent. With our angle theta set here, this leg is now x minus a. This adjacent leg is now a. Solving for this opposite leg, we can use Pythagorean theorem to arrive to the square root of x minus a quantity squared minus a squared. Going back to our integral, substituting x over a minus 1 quantity squared with secant squared theta and our dx with a secant theta tan theta d theta, we can now bring this a out and multiply with this a, giving us a squared. Also, secant squared theta minus 1, rewriting it as tangent squared theta. Simplifying things, we'll get this. And turning tangent squared theta into secant squared theta minus 1, now we can multiply secant theta to both of these terms, giving us this. We can integrate both of them individually, turning into this. Now secant theta is a known integral, meanwhile secant cube theta is not. So we can solve it in a separate paper. So from here, secant theta cube, we can turn it into secant theta times secant squared theta. Using integration by parts, letting u be equal to secant theta. Differentiating both sides, we'll get du is equal to secant theta tan theta d theta. And what's left will be our dv, which is secant squared theta d theta. Integrating both sides, we'll get v is equal to tan theta. Now from that, the first term of our integration by parts formula is the product of u and v. So we'll get this minus the integral of the product of v du, which is this. Simplifying things further, we'll get this. Turning tangent squared theta into secant squared theta minus 1. Now we can multiply this secant theta to both of these terms, giving us this. Now we can perform this individually, giving us this. Take note that a negative times a negative will give us positive. So from that, what we're really doing is just integrating this. So we can equate the integral of secant cube theta d theta to this. And what I've noticed, we have a negative integral secant cube theta d theta. We can transpose it to the other side, giving us 2 of these. Adding them will give us 2 times the integral of secant cube theta d theta. Solving for this alone, we can divide both sides by 2 and we'll get this. Now what's left to do is integrate secant theta d theta. And since it's a known integral, we'll get the ln of the absolute value secant theta plus tan theta. So now we can plug this into our integral of secant cube theta d theta in our original problem, giving us this. So from here, we can distribute a squared to both of these terms, at the same time performing this integration. Now from here, we can add like terms. A squared over 2 minus a squared will give us the difference of negative a squared over 2. Now from here, we can return things in terms of x. So with the definition of secant being hypotenuse over adjacent and tangent being opposite over adjacent, and with our right triangle we made earlier, we can say that secant is x minus a all over a, and tangent being the square root of x minus a quantity squared minus a squared all over a. Same goes with these two. So from here, this a squared gets cancelled out by these two a's, and these two fractions having the same denominator, we can add them, now giving us this plus c in the end as our constant.